Look out over the city of Kampala. Between the buildings and the ground, it looks like there's nothing but an empty void. But you are actually standing at the bottom of a massive ocean of matter. We swim in this ocean every day. When you light a charcoal stove to cook a meal, or notice an old iron roof starting to turn brown and leak, you are watching invisible chemical reactions happening between the air and the objects you use every day. Air is a physical mixture of several different gases. They float right next to each other, but they aren't permanently locked together. Think of it like a bowl of mixed nuts. You have peanuts, cashews, and almonds all sharing the same space, but they each remain their own separate ingredient. Realizing that the air is a measurable recipe of these distinct ingredients is the first step to understanding everything from how we cook our food to how our climate is shifting. This is the specific recipe for clean air. We can visualize the entire atmosphere as a single pie, divided into 4 clear slices. The largest slice, about 78%, is a gas called nitrogen. Nitrogen is extremely stable and unreactive. It serves as a calm buffer for the rest of the atmosphere. The second largest slice is oxygen, which makes up 21%. This is the active worker of the atmosphere, the ingredient that drives the chemical changes we see around us. The remaining tiny slivers are made of argon at 0.9% and carbon dioxide, which makes up just 0.04%. Because these gases are only physically mixed together rather than chemically locked, each one is free to perform its own unique job in our environment. Let's focus on that 21% of oxygen. Because it is so reactive, it is the absolute requirement for burning, a process scientists call combustion. Think about a charcoal stove. The fuel needs a constant supply of oxygen to keep the fire alive. If you cover the stove with a heavy blanket, you cut off that supply, and the fire dies instantly. In this reaction, the carbon in the charcoal permanently combines with oxygen from the air to form a new compound, carbon dioxide. Oxygen also works much more slowly. When an iron roof starts to decay and turn brown, you are seeing another form of oxidation called rusting. For this to happen, both oxygen and water vapor must be present at the same time. Without both ingredients hitting the metal, iron cannot turn into this brittle oxide. Oxygen is the invisible engine driving these changes, constantly transforming basic elements into the oxides we see in our daily lives. If oxygen is so vital, we need a way to separate it from the nitrogen in the air so we can use it whenever we need it. At specialized facilities like Mulago Hospital, patients with breathing difficulties rely on pure, concentrated oxygen. To help them, we have to extract that oxygen from the mixture of the atmosphere. This fractional distillation process exploits different boiling points. First, air is filtered and cooled below -200 degrees Celsius until liquid. Pumped into a column, it slowly warms. Nitrogen boils first, rising to the top. Oxygen boils later, tapped through a separate pipe below. Since air is a physical mixture, we can use these simple physical traits, like boiling points, to harvest life-saving gases from the air around us. This atmospheric mixture is a delicate balance. When our activities force unintended ingredients into the recipe, the quality of the air changes. Air pollution occurs when we release excessive amounts of harmful particles and exhaust fumes. These pollutants alter the natural composition of the air we breathe. This chemical disruption leads to severe consequences. It causes respiratory diseases like asthma, traps the sun's heat to drive global warming, and creates acid rain that can destroy crops and pollute our lakes. Local pollution is an active rewriting of the atmospheric formula we rely on, turning a life-sustaining mixture into a threat to our health and our environment. The air we breathe is a complex, dynamic mixture, dominated by a stable nitrogen buffer and a highly reactive oxygen engine. Understanding this chemistry explains the world around us, from knowing why we paint iron to stop it from rusting, to engineering the medical oxygen that saves lives. Protecting the natural balance of this mixture is the only way to preserve our own health and the Ugandan environment. Every time you light a stove, take a breath, or see a rusting nail, you are witnessing the tireless, invisible chemistry of the air driving the world around you.